All right, moving on, we're going to look at quadratic functions here in Module 7. So we just got done with linear equations, solving linear equations, solving linear applications. Now we're going to do the same thing with quadratics. We're going to solve some quadratic equations, and we're also going to talk about the graphs of quadratic functions, talk about their characteristics, and then some quadratic applications. Now, in solving a quadratic equation, our first step is to get our equation in standard form, and that's to set it equal to 0. Get everything on one side. So with that said, if you wanted to, we could go ahead and add this x squared over. I'm going to go ahead and add it. I like to see x squared as a positive term. And that would give me 0 equal to x squared plus 11x plus 24. Now with this example, right, I can easily factor. So I'm going to go ahead and do that one. So I can see the two linear factors. This one factors nicely using integers. So I'm going to go ahead and do that. So we know in factoring, we look at our front term. Let's get our two linear factors of x. Every quadratic, right, trinomial has two linear binomial factors that we can create here. So there's our x and x up front, which makes a product of x squared. And our goal, right, when we're factoring, is to look at our constant term and find a factor combination, right, of 24 that'll work together to make this middle term happen. And when I say work together, the outer and inner product are going to have to combine to get 11x. Now, what are our factor combinations for 24? We got 1 and 24, we got 2 and 12, we got 4 and 6, we have 3 and 8. And I notice 3 and 8, I like those. They're going to help me. So if I look at putting 8 and 3 or 3 and 8, doesn't matter the order. Right now, if you look at this, our product, we've got a 8x here on the inside, and then we got a 3x on the outside. Well, yeah, if you were to add those together, what do you get? You get 11x. So we need to make both of those a plus, right? So if you were to multiply 8 times 3, you're going to get the 24, and the outer and inner product going to add up to 11x. So there I am factoring my quadratic down to its two linear factors, and then we're ready to use the zero factor property, right, from algebra. So if we have a product equal to 0, then we know one of its factors in that product is going to have to equal 0. So we take each factor and set it equal to 0 and solve for x. So x plus 8 can equal 0, or x plus 3 can equal 0. If one of those is 0, then we're going to get a product of 0 and we multiply. So that's the zero factor property, setting those factors equal to 0 and then solving for x. So to do that, now we got the easy part. We're just solving two simple linear equations. We'll go ahead and solve for x by isolating. So as we do that, we get our two real number zeros for this quadratic equation. X equals -8 or x equal to -3. Here are my zeros. So they're the solutions, right, for this quadratic equation. All right, let's do the same thing, example B. So this one's already in standard form, right? You've already got 3x squared minus 8x plus 7. You already set it equal to 0. With that said, I don't see the factors. This is not one I can look at with integers to build the two linear factors. So here's where I'm going to review. Let's solve this one using the quadratic formula. So we went over the quadratic formula, which we can use on every quadratic. All right, but if I see the factors, then yeah, I would go ahead and use the factoring method, right, or square root method, depending on what type of equation we have as far as solving it. But this one may be a good one to use quadratic formula because I can't look at this one and see what my factors are going to be. And you'll see why in a minute. But we know with the quadratic formula, if we can put our quadratic standard form, set it equals 0, we can identify the coefficients, what we call A, B, and the constant term C, and plug them into this formula and get our answer. So the quadratic formula reads -b plus or minus the square root of b squared minus 4ac, which is what we call the discriminant of the quadratic. It'll tell you what type of solutions you're going to get, whether they're real numbers, whether they're complex numbers. So let's go ahead and use that. So again, this example, so when I say a standard form quadratic, so remember ax squared plus bx plus c, needs to equal 0. So we have that here. So we have A, we have B, and we have C. So A is equal to 3. All right, B equals -8, and C equals 7. So X is equal to -B, -8, plus or minus square root B squared, -8 squared, minus 4AC, 4 times 3, times 7, all divided by 2 times 3. So I plugged in my number. That's my solution to this quadratic. Now, unfortunately, we won't leave that as our answer. We got to simplify and make it look better. So that's where your work will be in the quadratic formula. Now, negative of -8 is +8. So there's the -b as we simplify. Plus or minus square root. -8 squared is 64, right? -8 times -8. And then we got -4 times 3, which is -12. And then -12 times 7. 12 times 7 is 84. So I got a minus 84 here. So we multiply those together. Now, with that said, as we look at that, notice what happens underneath the square root. We're getting ready to get a negative number. I've got 64 minus 84. It's -20. Well, negatives are undefined in the real number system. So at this point, right, with that negative right here, we have no real numbers, no real number solutions. We can define it, and I'm going to take it a step further. All right, we're going to define these solutions. They're quadratics. It's a quadratic with complex number solutions. So I'm going to define I. Remember, I equals the square root of -1. So if you're looking at finding our solutions, there's two complex number solutions. So we end up with 8 plus or minus. Now, square root of -20, let's introduce I. That's -1 times 20 over 6. So we have 8 plus or minus square root of -1 times the square root of 20 over 6. And there's I. So let's go ahead and introduce that. So we know that equals I. So we're simplifying down. You're getting ready to see your complex number solutions. Numbers form by adding multiples of I. So I got 8 plus or minus I times the square root of 20 over 6. Now I want to rationalize square root of 20. So I want you to write it up here. Square root of 20 is what? That's square root of 4 times 5. So if you have a perfect square factor, right, like we do in this one, like square root of 4, right, that rationalizes down to 2 square roots of 5. So this is equal to 8 plus or minus 2 square roots of 5 times I over 6. So just simplifying that down. And then we could divide out common factors and reduce this a little bit. So I'm going to write it down here and simplify a little bit. We got 8 over 6, right, plus or minus 2 square roots of 5 over 6, I. And then our common factor comes into play, right? We can divide out a 2, right, and reduce. So same thing here. As we divide out a 2, we get 1/3. So this reduces down to, dividing out our common factor of 2, we get 4/3, right, plus or minus, what, square root of 5, 2 6 is 1/3, square root of 5/3, I. So they're the imaginary. So there's two complex number solutions. So these are complex numbers. So we'll make that note. So you see one of your scenarios with quadratics, you can have two real number solutions like our last example. Here you have one with no real number solutions, which gives us complex numbers for solutions. All right, moving on. All right, with that said, let's go to example C, and I see in example C that I've got another quadratic, right, which this one not in standard form. So the first step on this one, I need to go ahead and set it equal to 0. So we need to go ahead and move that 1 over. So that'll give us 9x squared plus 3x minus 1 equals 0. And then again, like my last one, I don't see, looking at the factors of this one. So I'm going to go ahead and use my quadratic formula. So go ahead and write that down here, and we'll go apply it. So with that said, we got x equal to negative b. So remember, here's a, here's b, and here's c. So a is 9, right? B equals 3, and c equal negative 1. So x equal to negative b, negative 3, plus or minus square root of b squared, 3 squared, minus 4ac, 4 times 9 times negative 1, all divided by 2 times a, 2 times 9. And as we simplify, well, what do we get? We get negative 3 plus or minus square root of 3 squared is 9. There's b squared. Minus 4ac. Minus 4 times 9 is negative 36. Negative 36 times negative 1 is a positive 36. That makes two negatives make a positive. We multiply. All divided by 18. So right now I got negative 3 plus or minus the square root of 9 plus 36, which is 45. Now here's where I want to rationalize. So when I see this square root, right here, square root of 45, we need to rationalize that. So square root of 45 equals square root of, I got a perfect square factor. Square root of 9 times 5, right? Square root of 9 times 5 is 45. So square root of 9 times square root of 5, which I can rationalize. We know square root of 9 is 3. It's a perfect square. So it ends up being 3 square roots of 5. So I've got negative 3 plus or minus 3 square roots of 5, all divided by 18. And then I'm ready to divide out that 18 that's in the denominator. Let's go ahead and separate it, and then we'll look for common factors. Always, again, try to reduce. Look for any factors that are common in the numerator denominator. And you can see we do have a common factor of 3 showing up. So we can divide a 3 out for both of these. 3 times 1 is 6. Here we got 1 and 6. So I've got negative 1/6, right? Reducing that first fraction, negative 3/18, reduced to negative 1/6. Plus or minus, what? Square root of 5/6. So looking at our term. So here we have two real number solutions. So here's x. What does x equal? We've got two different solutions. X equal negative 1/6 plus square root of 5/6, or negative 1/6 minus square root of 5/6. We want to separate it, right? A lot of times they'll ask us to list our answers separated by a comma.